Welcome to a new test and teardown video. Yes, this time we're going to talk a little bit more about homebrew equipment. This one is of course completely homebrew, and I gotta admit, this is something I made in 1992. You're not going to believe it. I was 22 years old and I wanted a hi-fi amplifier for my car, and I couldn't afford one that was powerful enough, so I thought, hey, how about I build one myself? This one is definitely powerful enough. So everything is built completely from scratch. I don't know if you can imagine how big this is, but if you have my hand here, it's I think it was, let's see, yeah, 37 centimeters, and the heat sink is 11, and the height of the fence is like 4.5 centimeters. So it's quite some size. So those two screwed on the back side of the subwoofer is occupying what, a half a square meter. Oh, that's funny. So yeah, let's talk a little bit about how I made this thing. Here is the input from a local battery, because I couldn't pull this kind of peak current from the car main battery, because that would require a much thicker wire. So I had to have a local battery, an extra car battery, very close located to the power entry. And we got some capacitors here, 16 volt rated capacitors, 14,000 each, to keep the input voltage steady enough for the peak pulses. And then we go down to a local auxiliary power supply. That one is a little power supply for the push-pull driver, and that one is an UC3825 push-pull switch mode regulator controller. It's super easy to use this. You can do voltage mode, current modes, and all those kind of things. Really nice. So everything here is set up for that. And here we got the two primary field effect transistors. Of course, the most powerful stuff you could possibly find in 92. Local decoupling directly at the FETs, and look at that beefy sensor tapping of the half bridge push-pull. I gotta say that I rewound the transformer quite a few times, and it should have been a little bit bigger, but I didn't have enough room here, and I was actually getting a little bit tired of doing all sorts of reruns on the transformer. So what I did instead, I simply added a fan to prevent those wires from melting, and also to cool down the transformer, because I was running 800 watts of peak pulses through this one, and so that was absolutely crazy. So that's all the output rectifiers for the plus minus output, and here it's regulated. So this is this output voltage sense. It's only regulating on the positive, and then the negative is just unregulated. Of course, it's a completely balanced output audio amplifier, so that means all current use is going to be exactly the same on the positive and the negative rail. So it is okay just to regulate on the positive, so that will be the feedback voltage and the voltage adjustment point. So this one is doing a plus minus 25 volts, and it goes via those beefy cables here and a power connector like that. Yes, oh, that is funny. So all the pins here in the middle, those are connected for the center, for the ground, and that's of course the positive and the negative supply. There is of course almost no current going in the center wire because it's a push-pull balanced construction of the amplifier. So yeah, that's a you can just barely lift this monster of a power supply. So let's look a little bit on the audio amplifier. This is a linear class AB. It is running with very little idle current. The bias is very low, and so there's a tiny little bit of crossover distortion. But really, in a car, it's not meant to be high-end audio. I just wanted this thing to play really loud, and I adjusted the bias so it is so it plays really nice, and it's not consuming a lot of idle power either. And during the design phase of this, I figured out a way to adjust all the biasing and all that kind of stuff, so it was nice and stable without emitter resistors. So I can't actually tell you exactly what was the super nice trick because I've forgotten it and I haven't got the schematics, but it's actually quite easy to figure out more or less the schematic by just looking at it, right? Because it's just 3 amplifiers, more or less the same. As you'll see here, we got the plus minus 25 volts coming in, and then we got, of course, local capacitors. So this is the right channel, 200 watts of peak output power here, and that is done by the 25 volt is positive and negative, right? And then it is bridged, so it's an output that is balanced, and each side of your speaker can go to plus minus 25, almost. Minus a few volts. Here is the pre-driver that's driving the output stage, and there will be some local feedback here and kind of stuff like that, and then it goes to the op amps and all that fancy stuff here. So yeah. So between those, you'll have almost plus minus 50 volts. That is funny. And as this left and right speakers, that's 4 ohms. So that's 7 amps peak in the speakers. And bass speaker, that was 4 parallel 8-inch speakers. So that is about 2 ohms. So that of course require a lot more transistors in parallel to be able to drive all that voltage in that very low impedance. So here you go, more transistors in parallel to do that job, and again everything is bridged, and that is of course the left channel exactly the same. So yeah, pretty funny design. I gotta say that I think I spent a lot of hours making this one, but I also had it for many years, and it was really powerful. Absolutely top class. I had so much fun with it, and I actually think it still works. Yeah, we got some potentiometers and yeah, transistors and op amps and stuff here. So yeah, crazy DIY power supply and audio amplifier project. You can see the heat sinks, they are actually salvaged from another project, and I can't really remember exactly what it was I took to pieces here, but you can see the design of the heat sinks. So I think they were mounted like this, side by side, and it was one of those cooling tunnels. A big power supply probably, right? Maybe we could try and boot up the power supply and see if it works. I don't know if I got anything that's capable of doing that. Oh no, we got some corrosion and stuff. I was actually going to throw these out because they occupy quite a lot of space, and I mean, they've been on my stock now for 30 years, so I think it is time to put them in the bin. But one last have fun with this thing. Yeah, let's try and see if we can blow this up. So here's my test of the 30-year-old power supply. I connected the outputs to my two loads. I'm just using one tiny little power supply to see if I can power it up. I connected them in parallel, and we don't see any shorts, so that can't be bad. So here's how it works. The green wire was the official go on signal back in the days. So if I connect this one, the fan goes on, but I don't have any output. Ooh, that sucks. So that's not good. Yeah, output comes. Okay, that was a slow start. Yes, I remember. Okay, I got it. So this is the unloaded voltage. It's not perfectly symmetric. It's of course not designed for being completely unloaded. Let's try and turn it off again. Again, it's only regulating on the positive, so the little glitches and stuff on the negative will pull the negative a lot higher. But it could be fun to see if we could load it a little bit. The idle was about 8-9 watts or something like that, right? I think I'll try and turn it on again. Let's try and current 0.1. Current 0.1. So now we are loading the two outputs. So that's a little bit better, right? So that's my 12 watts and 12 watts, so that's 24 watts of output. And here's my input is about 50 watts. And of course this is a lot of idle, but not a big problem for a heatsink this size. But I think this this idle, or this efficiency, is going to be of course a lot better when we crank up the load. But I'm not going to bore you with any of that. It's just fun to see that it's actually still working. It's probably a lot of nasty loss anyway here. Where's the 50 watts going? I think I'll take my thermal camera and have a look where's all this going. So it's still running with my load here. What you see is that is the converter IC, and yes, they are known to run pretty warm, and 50 Celsius. So that's my snubber filter components. And what else is running warm? So that will be my power supplies. Not that bad. What else is? Oops, that's the wires. Or something like that, right? Yeah, that's the transform. That is the core, the primary side of the core. Let's try and get the macro. Yeah, exactly. So all the loss we see right now is actually transformer core. And the fan. That's funny. Anything else is definitely not getting warm at the moment. Oh yeah, by the way, I think I said something about bias, and that is definitely a lie. When an amplifier is made like this, without emitter resistors, and as you can see here, in the bridged output stages like that, right? So that will be the output, and that is the other side of the bridge, and all the two base connections here, they're in parallel, two base connections here, they're in parallel to each of their drivers like that. This means there is, of course, no bias. So this is a class C linear amplifier. So we just gotta have this right. But the fast op amps here that control each side, they will of course handle this as good as they can. So you will get a smooth and nice sine wave output no matter what, because it's there's a feedback, right? See, here's the feedback point from each of the two halves. Could be fun to see if I could actually get some audio through one of the amps. Now I got a power supply that is running. I think always it's more fun to put this in the video, the first power up test, or to see if something works. So that will be the input. I believe that is the input to my left side. Oops, I'm an idiot. I put my scopes on the right. Oh man, I need to move that wire. Okay, so here we go. That will be the input from the signal generator. That goes now to the right. If this is correct, I don't know. Well, there's a yellow wire here that goes to the drivers down there, so maybe that is correct. And then the scope channels, of course, they are on both of the outputs because they go balanced. And let's try and crank on the input voltage, and let's turn on the power supply. And remember, it takes quite a while before it slow starts, so that is intentionally, otherwise it's going to short circuit the input. Now it's powering up, and we got 0 volts, and that is all goody. So let's try and input. Yeah, we got a little bit of input. So let's give it some more drive. Oops, clipping. So that is just about it. So that is 10 volts per division. Funny, one of them is clipping. Oi, 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 oi. That is a little bit funny. Why is it doing that? So we have some funny things. Oh, it's also a little bit higher, the amplitude, so that is why it's clipping. So there's a kind of a balance there. Ah, that is probably one of the adjustments down here. Oh, that is interesting. Of course, I This is 30 years old, and it's of course not perfect anymore. But there is output. So that is 1 kilohertz. Let's see how it behaves. Full drive, 10 kilohertz, 20 kilohertz, and that's the same. Great. So this is the 1 kilohertz again. So this is the right channel. It's not supposed to be a bass channel because there is a subwoofer channel. But let's see how it behaves at 100 hertz. And see, now it's getting low. And now the bass amplifier will take over, because there's an active filter here that's doing all that kind of stuff. So speakers, they go directly here without any filters and stuff, because that's just gonna blow up anyway. It's much easier to have it in the signal path, all your filters, and then at 100 hertz and below, see, then the bass amplifier will take over. So let's go back to 1 kilohertz. Let's look a little bit at the crossover. I think I will try and give it a lot less drive. Let's see if we can do that. So tiny little drive and then crank up. Oopsie doopsie here. See if I can figure this out. Ooh, we got some noise. So here we go again. I just adjusted the trigger and all that kind of stuff. And what you see here of noise is probably the switch mode, and probably also my light that is affecting this, because we got gain here. We got just wires all over the place, and now we have a very low level. Now you can see the switch mode converters cranking in. So this is 10 millivolts of input drive, a very weak signal. But you don't see the crossover. What you see here is, yeah, probably oh, my power supplies and stuff. That's funny. Yeah. So it is definitely working in class C mode. Not too bad. I don't want to talk a lot more about this amplifier. It's just fun to see that it still works. Thank you very much for watching, and have a good day. Bye bye.